In this question, it is given that if A cross B is equal to C plus D, then the correct alternative is. So over here, just try to understand what this question is exactly trying to say. Assume that we are just considering a surface something like this. So we need to like imagine it, because A cross B is perpendicular to the direction of A vector and B vector. So if I am just considering different plane over here, that means assume that this is our x-axis and this is our y-axis and this is our z-axis. So now everyone is getting an idea that this is nothing but our x-z plane and this is nothing but x-y plane over here. Now assume that our two vectors, let's say A vector and B vector. So assume that this is, I'm just considering this is my B vector and this is my A vector. So if I are going for A vector cross B vector, I'll get a vector which is perpendicular to this xz plane, or that will be along the y-axis. So let's say this is our resultant of A cross B. Now in question it is given that A cross B, just observe the question, it is given that A cross B is equal to C plus D. Means the A vector cross B vector is same as like the vector addition of another two vector. Let's say one is C vector and D vector. So this is the meaning of question. That is A cross B is this vector. Let's say I'm just writing that vector as nothing but E vector, and C plus D is also equal to E vector. Just try to imagine it. C vector and D vector is in y-x plane and E is along the y-axis and A and B are in xz plane. Now you can just understand that B is first option. Just observe the first option. B is parallel to C plus D. So just observe B. Is it parallel to C plus D? C plus D is nothing but E. So B is not parallel to that. B is perpendicular to that. So we can say that first option is wrong. Second option, you can observe that A is perpendicular to C. So it's not like over here also you can observe that it's not necessary that this A is going to be perpendicular to C, or A is perpendicular to D, or E is perpendicular to A. So we can say that the second option is also wrong. Now it is given that the component of C along A is equal to component of D along A. So just try to understand what is the meaning of this. Now if you are just observing that xy plane, so there we discussed that there is a vector along this direction, this we take it as nothing but C, and there is a vector along this direction, this is taken as nothing but D. And if you are going for C vector plus D vector, we'll get a resultant vector as nothing but E. Now if you are observing the component along the horizontal direction over here, so the resultant vector is along the, or in a direction perpendicular to this line, perpendicular to this line. So the resultant vector is along this direction. That means the component of C along this direction and component of D along this direction should get cancelled. So once again I'll try to explain it. It is something like this. Our C vector is nothing but this vector. Let's say this is our C vector. Now this is nothing but our D vector. If I'm just taking this D vector in such a way that, so if I'm taking this D vector parallel to itself, so we can keep this D vector over here. So just observe that we can keep this D vector over here, and the addition of C vector plus D vector should be perpendicular to this. That means if just assume that the angle made by the C vector with respect to the horizontal is equal to, take it as theta 1. So the component of C along this direction can be written as nothing but C cos theta 1. Same as like if this angle is equal to theta 2, the component of D along this direction can be written as D cos theta 2. Now these two components should have a same magnitude and opposite direction. That's why the resultant vector is perpendicular to this line. Got it? So C cos theta should be cancelled with D cos theta 2. So which is given in the third option or in fourth option. The component of C along A, the component of C along A is equal to component of D along A. They are not just equal, but they are having opposite direction. So we can say that component of C along A, or in the plane containing A, is negative of component of D along A. So we can say that the component of C along A, along this horizontal direction, or along the plane XY, along that X Z plane, is equal to negative of, it is in the opposite direction, negative of component of D along A. So we can say that this D option is correct.